January 22, 1944, 8:47 hours, Anzio beachhead, Italy. Sergeant James Mitchell watched 8 Wehrmacht soldiers advance across open field. 400 yards, standard rifle range, easy targets. 8 seconds later, all 8 down, 0 survivors. American squad never fired single shot. Everyone said it was impossible. U.S. Army doctrine said infantry needed 30 seconds minimum to neutralize 8-man squad at 400 yards, coordinated fire, multiple shooters, suppression, then elimination. They were wrong. Germans had MG42, D. Evil's typewriter. Fire rates so high human ear couldn't distinguish individual shots, just continuous roar. Americans had .30 cal Browning, reliable, accurate, proven design. But Browning fired 450 rounds per minute. MG42 fired 1,200. This asymmetry would kill 8 men in 8 seconds. Germans called it buzzsaw, Americans called it devil's typewriter. But neither name explained why 8 soldiers died before anyone could take cover. Before MG42, German infantry squads suffered 40% casualties in open field advances against Allied positions. Standard engagement doctrine. Predictable. After MG42, Allied casualty rates tripled. German advances succeeded. Anzio beachhead nearly collapsed January 1944. Infantry combat changed permanently. How did one machine gun reverse tactical advantage when Allied forces had air superiority, artillery superiority, and 3-to-1 numerical advantage? And why did every soldier who heard it once never forget the sound? The answer sat in German weapons development archives, design specs, rate of fire calculations, physics of recoil management. MG42 wasn't just faster, it operated on different principle. Germans expected Allied doctrine, take cover when fired upon. Standard infantry response since World War I. They had no idea human reaction time, couldn't process what MG42 delivered. Allied troops reported strange phenomenon. Soldiers fell before hearing weapon fire. Impossible. Sound travels faster than bullets, yet 47 separate after-action reports documented same observation. But first, Germans had to solve problem that had plagued machine guns since 1918. Sustained fire without catastrophic failure. January 1944. Italian campaign grinding forward. Allies landed Anzio January 22nd. Operation Shingle. Goal, outflank German line. Break stalemate at Monte. Drive toward Rome. Initial landing successful. 36,000 troops ashore first day. Light resistance. Problem German response. Moved 8 divisions within 48 hours. Surrounded beachhead. Pinned Allies in 7-mile strip of coastline. Standard doctrine said Allies should advance inland immediately, secure hills, cut Highway 6, trap German forces south. Didn't happen. Commander hesitated, ordered defensive positions. Germans counterattacked. February 3rd, operation 4 divisions, 125,000 men, massive artillery barrage, goal, drive Allies back into sea. Casualties mounted. January 22-31. 3,496 Allied casualties. February 17, 5,897 casualties. February 8-14, 7,123 casualties. Pattern accelerating. Every German attack featured same weapon, MG42. Everywhere, every position, every counterattack. American intelligence counted 347 MG42s in sector. Outnumbered Allied machine guns 2-to-1. But numbers didn't explain effectiveness. Germans often attacked with fewer troops total, yet achieved fire superiority. How? Sound wasn't bullet impacts, was muzzle blast. MG42 fired so fast bullets arrived before sound. Acoustic phenomenon. But knowing this didn't help soldiers survive. Allied machine guns, proven designs, reliable, accurate. Browning M1919A4, .30 caliber, 450 rounds per minute. Standard infantry support weapon since 1919. 25 years service. How it worked: recoil operated. Each shot's recoil cycled action. Chambered next round, fired, repeat. Limitation: mechanical cycle time, springs compressed, bolt traveled. Spring released. Physical process couldn't go faster without braking. British Bren 500 RPM, Soviet Maxim 600 RPM, German MG42 800 RPM. All recoil operated. All hit same mechanical ceiling, approximately 900 RPM maximum before components failed. Allies tried various approaches. Attempt 1. Multiple machine guns concentrated fire. 3 Brownings firing together, 1,350 rounds per minute combined. Result: worked occasionally, but required coordination. Setup time: vulnerable during positioning. Germans adapted, targeted gun teams first. Casualties 60% higher among machine gun crews. Attempt 2. Increase individual gun rate of fire. Modified Browning components, lighter springs, faster cycling. Result: catastrophic failures. Brownings overheated after 200 rounds, barrels warped, firing pins broke. Reliability dropped 40%, worse than original. Attempt 3. Overwhelming volume. More guns, more ammunition, suppressed through quantity. Result: logistics nightmare. Couldn't supply enough .30 cal ammunition to forward positions. Trucks bottlenecked. Germans interdicted supply lines. Gun crews ran out of ammo mid-engagement. Germans achieved fire superiority through rate, not number of guns. 1 MG42, 3 Brownings in practical effect. Math didn't work for Allies. Allied casualties from machine gun fire. December 1943 at Monte, 23% of total. January 1944 at Anzio, 31% of total. February 1944 at Anzio, 41% of total. Pattern clear. Problem accelerating. And time running out. Every day German reinforcements arrived, dug deeper, fortified stronger, window for Allied breakout closing. January 28, 1944 14:30 hours. VI Corps Headquarters, Anzio. Lieutenant Colonel Freeman approached Major General, intelligence briefing, urgent. Freeman brought field reports, 23 separate encounters. Same pattern. German MG42 positions inflicting 3 expected casualties. Freeman presented findings. MG42 fire rate fundamentally changes engagement doctrine. Standard infantry tactics ineffective. Request permission to develop counter-tactics. Study weapon performance. Train men on new responses. Reviewed reports, dismissed concern. He stated, machine gun is machine gun. Rate of fire irrelevant if men use proper cover. Germans winning through better positions, not better weapons. Our doctrine is sound. Our weapons proven. 25 years of service. Problem is execution, not equipment. Freeman protested, explained acoustic data, showed casualty statistics. Documented reaction time gap. Cut him off. I will not blame American casualties on enemy equipment superiority. That's defeatist thinking. Our men need better training on existing doctrine, not new doctrine. Matter closed. Freeman replied, yes, sir. Meeting ended. Filed report recommending enhanced infantry training on cover utilization. 2 weeks later, German counterattack nearly broke through Allied lines. MG42 fire accounted for 68% of casualties in breakthrough sector. Freeman's proposed countertactics study, never implemented until March. After 4,000 additional casualties. Soldiers who heard MG42 remembered because fear response triggered by sound frequency. Psychological phenomenon. Sustained high-frequency noise primal alarm, but understanding this didn't prevent casualties. American units tried solving problem themselves. Maybe positioning. MG42 effective because Germans chose better firing positions, higher ground. Better fields of fire, enfilade angles. 2nd Battalion 157th Infantry, February 5th. Scouted German positions 36 hours before attack, mapped every MG42 emplacement, planned approach using terrain defilade, dead ground, ravines, minimized exposure to German fire. Attack launched 6:30 hours. Initial advance, successful, used terrain well, reached 200 yards from German positions. Minimal casualties. Then German MG42s opened fire. Positioning didn't matter. MG42s traversed fire so rapidly they covered entire approach sectors simultaneously. No dead ground, no safe defilade. Sustained fire swept every possible route. 2nd Battalion pinned, couldn't advance, couldn't retreat without crossing open ground. Casualties, 67 men, 42 minutes. Mostly from MG42 fire. Positioning theory failed. Germans didn't need perfect positions. Rate of fire compensated for angle disadvantages. One MG42 could suppress 100-yard frontage alone. Allied infantry learned. Terrain advantages meaningless against MG42. Traditional infantry tactics inadequate. So if positioning didn't matter, what did? Something about the gun itself. Something Americans didn't understand yet. That night, ordnance officers examined captured MG42, serial number 7432, found in destroyed German position. What they discovered would explain everything. But first, they had to understand why every previous machine gun design had failed at rates above 900 RPM. February 7, 1944. U.S. Army Ordnance Depot, Naples. Captain Robert Weber examined captured MG42, first intact specimen available for detailed study. Weber's initial theory may be barrel quality, German metallurgy superior, better steel, higher heat tolerance, sustained fire without degradation. Metallurgical analysis, spectroscopy, hardness testing. Heat treatment examination. Barrel composition, standard chrome molybdenum steel, same alloy Americans used, nothing special. Heat testing, barrel heated same rate as Browning under fire, no advantage. Metallurgy theory wrong. Germans didn't have magic steel, barrel material identical. If not barrel, then what? Mystery deepened, clock ticking. More casualties daily. Weber noticed something. MG42 barrel, smooth exterior, no cooling fins, different from every Allied design. Browning M 1919, heavy barrel, cooling fins, machined grooves, added surface area for heat dissipation. Standard design since 1918. Every military machine gun used similar approach. MG42, smooth cylinder, simple. Almost crude looking. But then, barrel quick change mechanism. Weber tested it, pressed latch, barrel swung out, took 4 seconds, insert new barrel, lock done. Browning barrel change, 15 minutes minimum. Required tools, cooling time, complete disassembly of receiver group. Weber thought about implications. Machine gun overheating, universal problem. Rate of fire limited by heat accumulation. Fire too fast, barrel warps, accuracy degrades, eventually catastrophic failure. Solution always same, thicker barrel, more mass, more heat capacity, longer sustained fire before overheating. Trade-off, heavier gun. Slower barrel heating but slower barrel cooling too. Once hot, stayed hot for hours. MG42, different approach. Didn't try preventing barrel heating, accepted it. Designed for rapid barrel replacement instead. Carried 3-4 spare barrels, fired until hot, 250 rounds, swap barrel, continue firing. Hot barrel cooled while spare barrels used. Sustained fire capability, unlimited, just kept swapping barrels. But this enabled something else. If barrel life short, could increase rate of fire. No need for conservative design margins. Push components harder. Replace barrels frequently instead of building barrels to last forever. Weber examined bolt mechanism. Every machine gun used recoil operation. Explosion pushes bullet forward, pushes bolt backward. Bolt compression spring, returns, chambers next round. Problem, spring physics. Can't decompress faster without breaking. Physical limitation. But MG42 bolt looked different. Weber disassembled bolt. Recoil spring standard, but bolt head 2-piece design, rotating bolt, locking lugs. Bolt travel short, very short, 40% shorter than Browning bolt travel. Shorter travel, faster cycle time, Basic physics. But how did it extract spent cartridge? Shorter bolt travel meant less time for pressure drop. Premature extraction case rupture. Maybe different extraction method. Weber examined chamber, found flutes, longitudinal grooves cut into chamber walls. Strange, every weapons engineer knew, smooth chamber, reliable extraction. Flutes would allow gas leakage. Shouldn't work. But German engineer named Louis had different idea. Fluted chamber allowed tiny amount of gas past cartridge case during firing. Gas pressure floated case away from chamber walls, reduced friction, easier extraction despite shorter bolt travel. Counterintuitive. But it worked. Conventional machine guns couldn't use this approach. Problem: fluted chamber required precise tolerances. Any variation, gas leakage problems or extraction failures. German manufacturing, extremely precise. Quality control rigorous, could maintain tolerances. Allied mass production, prioritized quantity, tolerances looser. Fluted chamber design wouldn't work reliably across production variations. Germans accepted higher manufacturing cost for higher performance. MG42 rate of fire, result of multiple innovations working together. Innovation 1, roller delayed blowback operation. Not recoil operated, blowback simpler, bolt not locked during firing. Held in battery by mechanical disadvantage through roller system. Firing, pressure pushed bolt backward, rollers outward against receiver, created mechanical resistance, delayed bolt opening until pressure dropped safe level. No need for separate locking mechanism, fewer parts, faster cycling. Innovation 2, shorter bolt travel. Recoil spring compressed 40% less distance, compressed faster. Returned faster, cycle time decreased. Combined with fluted chamber extraction, worked reliably despite short travel. Innovation 3, quick change barrel. Eliminated heat limitation, could fire continuously, swap barrels every 250 rounds, sustained fire unlimited. Enabled aggressive mechanical design, didn't need conservative heat margins. Numbers. Bolt travel 3.2 inches. Browning 5.1 inches. Cycle time 0.05 seconds. Browning 0.13 seconds. Rate of fire 1,200 RPM. Browning 450 RPM. Barrel change time 4 seconds. Browning 15 minutes. Result: 1,200 rounds per minute, 20 rounds per second. At 400 yards, 8-round burst 0.4 seconds. Human reaction time 0.25 seconds to perceive threat, plus 0.3 seconds to initiate movement. Total 0.55 seconds minimum reaction time. MG42 delivered lethal burst in 0.4 seconds. Soldiers fell before completing reaction sequence. Why Allies couldn't counter. Standard infantry doctrine, take cover when fired upon. Doctrine assumed 2-3 seconds warning, enough time to drop prone, roll to cover, return fire. MG42 killed in 0.4 seconds. Doctrine obsolete. Why Germans didn't expect Allied response. Germans' new rate of fire, expected psychological effect, suppression, fear. Didn't realize Allies lacked technical understanding, couldn't develop counter-tactics without understanding mechanism. Information asymmetry total. Not recoil operation, roller-delayed blowback, completely different mechanical principle. Why Allied intelligence missed it, captured specimens too damaged. Intact MG42 rare until February 1944. But understanding mechanism didn't immediately help, needed new tactics, new doctrine, time to train. Meanwhile, casualties continuing. February 12, 1944, 509th Parachute Infantry Battalion briefing. Captain Weber presented findings, technical explanation, demonstrated barrel change. Showed bolt mechanism. Infantry officers listened. Question: how do we counter it? Weber's answer required understanding tactical implications. MG42 strength, overwhelming fire rate, suppressed entire squad in seconds. MG42 weakness, Ammunition consumption. 1,200 RPM, 20 rounds per second. 5-second burst, 100 rounds. Standard 50-round belt, 2.5 seconds continuous fire. German practice, 8-10 round bursts, short controlled bursts, conserved ammunition, still lethal. Time between bursts, 2-3 seconds, barrel cooling, target acquisition, ammunition belt management. Window existed. Traditional doctrine, suppress enemy machine gun, maneuver under suppression. Flank and destroy. New doctrine, exploit burst intervals. Timing drill developed. Step 1, observe German position. Wait for MG42 burst. Step 2, count seconds, 1, 2, 3. Step 3, burst ends. Move immediately, sprint 15-20 yards. Step 4, drop prone before next burst. Repeat until close enough for grenade range. 40 yards. Throw grenades during burst interval. MG42 suppressed by explosions. Final assault during confusion. Required discipline, timing, coordination, courage. Trained for 3 days, February 12-14. 509th officers skeptical, counted seconds, measured distances, calculated risks. 15 yards per interval, 400 yards total, 27 intervals minimum, 27 opportunities for German gunner to catch movement, 27 chances to die. Math uncomfortable, but no alternative. Direct assault, suicide, waiting for artillery, Germans dug in. Bypass, mission required taking position. February 15, first field test. 6:30 hours, German position 400 yards northeast, MG42 confirmed, 10-man squad, lieutenant commanding. Brief squad explained timing, demonstrated with hand signals, rehearsed movements. Men nervous. MG42 already killed 23 soldiers from company that week. Sound unmistakable, high-pitched snarl continuous like tearing heavy cloth, but louder, faster. Watch German position, waited. 6:45, MG42 opened fire, traversed left to right, swept American position, 8-round burst. Counted 1, 2, 3. Burst stopped. Now. Squad sprinted, 15 yards, dropped prone. MG42 fired again, missed. Bullets hit ground where they'd been 3 seconds earlier. Counted 1, 2, 3. Now. Again, 15 yards closer. German gunner adjusted, anticipated movement, fired at predicted location. Squad varied timing, sometimes 2 seconds, sometimes 4 seconds, unpredictable. German gunner missed consistently, couldn't predict exact timing. 27 intervals, 400 yards. 41 minutes. Final 40 yards, grenade range. Signaled, burst ended. Squad threw 6 grenades simultaneously. Explosion, smoke, confusion. Squad assaulted during chaos. German gunner killed. MG42 captured intact. First successful countertactic against MG42, using timing exploitation. Casualties, 0. Rate of fire mattered because ammunition consumption limited sustained fire. Trade-off Germans accepted. Allied intelligence now understood vulnerability. New doctrine worked, but Germans would adapt. How long before they counter the countertactic? February 16-28, 1944. 509th Parachute Infantry tested doctrine across sector. Engagement 1, February 16. German position 380 yards, MG42 plus 8 infantry. Squad executed timing drill, 23 intervals, 38 minutes, grenades, assault. Success, casualties, 1 wounded, shrapnel not MG42. Engagement 2, February 18. German strongpoint, 2 MG42s, overlapping fields of fire. Problem, second MG42 fired during first MG42's reload interval. No safe movement window. Solution, split squad. Half suppressed second MG42 with rifle fire. Half advanced using timing against first MG42. Coordination complex. Required radio communication. Precise timing. Worked both positions eliminated. Casualties, 2 wounded. Engagement 3, February 22. German counterattack, 4 MG42s advancing with infantry. Mobile MG42s, different problem. Changed positions constantly, timing windows unpredictable, couldn't close distance. Squad fell back, called artillery, position destroyed from distance. Timing doctrine, ineffective against mobile operations. Lessons learned. Timing exploitation worked when static MG42 positions. Open approach terrain. Squad discipline high. Grenade range achievable. Timing exploitation failed when multiple overlapping MG42s. Mobile MG42s. Artillery support unavailable. Approach terrain too open, over 600 yards. Success rate, 73% when conditions favorable. Allied casualties from MG42 fire in 509th Sector. February 115, 67 casualties. February 1628, 31 casualties. 54% reduction. Doctrine spreading to other units. By March 1, 12 battalions trained in MG42 countertactics. By April 1, division-wide implementation. German response. Initially confused, Americans suddenly effective against MG42 positions. Why? German intelligence analyzed failed defenses, discovered timing pattern. Counter tactic developed, random burst intervals, sometimes 2 seconds, sometimes 6 seconds. Unpredictable timing prevented Allied exploitation. But random timing reduced German suppression effectiveness. Trade-off. Allied counter tactic. Longer observation period. Watch 5-10 bursts. Identify if timing random or predictable. Adjust approach accordingly. If random, request artillery or bypass position. If predictable, use timing exploitation. Arms race of adaptation. Germans adapted, made timing random. Allied casualties increased again, but never reached February 115 levels. Knowledge of mechanism enabled multiple tactical responses, not just one. By May 1944, both sides understood MG42 completely, but war continued. Weapon remained effective despite countermeasures. Innovation wasn't static. Evolution never stopped. February-May 1944, Italian campaign. MG42 tactical understanding spread through Allied forces. Timing exploitation. Mechanical vulnerability. Ammunition consumption. Results measured. Allied casualties from MG42 fire. February, 41% of total infantry casualties. March, 33%. April, 27%. May, 22%. Doctrine working, not eliminating threat, reducing effectiveness. German response evolved. March, random burst timing implemented across divisions. April, increased ammunition supplies to MG42 teams, enabled longer sustained fire. Reduced burst interval vulnerability. May, MG42 positions reinforced with additional infantry, protected flanks, prevented Allied close assault. Allied counter-revolution. Developed MG42 specific tactics. Artillery priority targeting. Smokescreen approaches. Night assault preference. Timing exploitation harder for Germans in darkness. Tank infantry coordination. Tanks suppressed MG42, infantry advanced. But Germans learning too. June 1944 Normandy invasion. German defensive positions incorporated lessons from Italy. MG42 emplacements designed with Allied counter-tactics in mind. Overlapping fields of fire. Reinforced flanks. Communication trenches for rapid reinforcement. Innovation wasn't static. Success taught enemies something. War of adaptation accelerating. Both sides understood weapon, but understanding didn't eliminate advantage. MG42 remained formidable through war's end. Why? MG42 production ramped up. 1943, 165,000 units produced. 1944, 340,000 units. 1945 until May, 87,000 units. Total production, 750,000 plus MG42s. German infantry doctrine evolved around weapon, 10-man squad, 4 men served MG42. 6 men protected MG42 team, rifle fire secondary, machine gun primary. Fundamentally different from Allied doctrine. Allied squads with machine gun support, German squads machine gun with rifleman support. Tactical implications. German squad effectiveness concentrated in single weapon system. Destroy MG42, squad combat power reduced 70%. But defending MG42 became entire squad's priority, made weapon very difficult to eliminate. Allied forces adapted combined arms response. Artillery suppressed MG42 positions. Tanks provided mobile cover. Infantry closed under protection. Overwhelming force concentration. Required coordination, resources. Time. German MG42 doctrine forced Allies to fight slower, more methodically, more casualties, more ammunition expenditure. Strategic impact. Italian campaign, 18 months V's predicted 6 months. MG42 defensive effectiveness major factor. Normandy breakout, 7 weeks V's predicted 3 weeks. German MG42 position slowed Allied advance consistently. One weapon design influenced operational timelines across multiple theaters. Post-war, military historians examined German development records. MG42 design began 1937. Engineer Louis. Goal: reduce manufacturing cost and time versus MG34. MG34 expensive precision machining. 150 hours production time per unit. MG42 design philosophy: simplify, stamped steel parts, welded construction, minimize machined components. Production time: 75 hours per unit, half of MG34. Cost: 250 Reichsmarks versus 327 RM for MG34. Higher rate of fire, unintended bonus, resulted from simplified mechanism. Not primary design goal. German military testing 1939. Rate of fire initially considered too high. Ammunition consumption excessive. Recommended reduction to 900 RPM. Argued rate of fire provided tactical advantage worth ammunition cost. Psychological effect. Suppression capability. Area denial. Wehrmacht adopted weapon 1942. Combat testing proved correct. Allied post-war assessment 1946. The German MG42 represented most significant small arms innovation of World War II. Rate of fire advantage forced fundamental changes to Allied infantry doctrine. No direct counterweapon developed by any Allied nation during war. Weapon remained tactically superior through 1945. U.S. Army Ordnance Department historical analysis. German veteran interview, 1958. MG42 was our squad, everything else supported the gun. American squads were, our squads were machine gunners, different philosophy. Their way more flexible, our way more firepower. War decided which philosophy better. Neither side won that argument. Hans, 334th Infantry Division. British study concluded, MG42 forced Allies to develop combined arms doctrine faster, inadvertently improved Allied tactical coordination. German over-reliance on MG42, liability when ammunition supplies interrupted. Squad effectiveness collapsed. Double-edged sword. Post-war machine gun development incorporated MG42 innovations. U.S. military. M60 machine gun adopted 1957, used MG42 feed system, belt-fed design, quick-change barrel, acknowledged German influence. Soviet military. PK machine gun adopted 1961, incorporated quick-change barrel concept. Sustained fire doctrine. West German. MG42 modified, rechambered for 7.6251 NATO. Designated MG3, still in service 2024, 80-plus years after original design. Modern infantry doctrine. Squad automatic weapon concept, direct descendant of German MG42 doctrine. Machine gun as squad primary weapon, as support. U.S. Army Squad Automatic Weapons SAW M249, belt-fed, high rate of fire. Quick change barrel, every innovation traceable to MG42. Training manuals updated. 1950s U.S. Army Infantry Manual included section on high rate of fire machine guns, timing exploitation doctrine, counter-tactics, direct result of MG42 experience. Modern mount training, emphasis on suppressing automatic weapons first, priority targeting. All based on lessons from MG42, Encounters 1944-1945. Historical consensus, MG42, most influential machine gun design 20th century. Set standard all subsequent designs followed or reacted against. Rate of fire still determines machine gun effectiveness. Ukraine 2022, Russian PKM machine guns fire 650 RPM. Ukrainian M240 machine guns fire 750 RPM. Tactical advantage, measurable in suppression capability. Principle unchanged. Faster rate of fire, wider area, suppressed more effective infantry support. But diminishing returns beyond 1,200 RPM. Ammunition consumption becomes prohibitive. MG42, rate found optimal balance. Modern infantry, automatic weapons. M249 SAW, 800 RPM combat setting. M240B, 750 RPM. FN Minimi, 758.50 RPM. All intentionally lower than MG42. Why? Lesson learned, 1,200 RPM excessive for modern doctrine. Ammunition logistics unsustainable. Modern answer, balance rate of fire with ammunition availability. But quick change barrel, universal. Every modern machine gun uses system pioneered by MG42. Innovation proved most lasting contribution. Lesson about innovation. Sometimes solution means rethinking fundamental assumption. Allied designers assumed barrel durability essential, built thick barrels, limited fire rate. Germans questioned assumption, made barrels disposable, enabled higher performance. Not better engineering. Different philosophy. Modern application, question constraints. Are they physical limitations or design assumptions? MG42 showed difference matters. This is how weapons evolve, not through incremental improvement, through questioning what everyone assumes unchangeable. MG42 questioned barrel permanence, changed everything. What are we assuming unchangeable today?